Any question before we get started? Okay, if no, then let's talk about what the goal today is to finish the probability probability part, and then later we'll talk about some Excel. Okay, and then the next class we do we'll do the quiz, and then we'll give you assignment 1. So that will be the plan for this week. Any question? No? If no, then we immediately go to the slides. So I guess it will be fruitful to summarize what we have learned in last class, because I guess that would be over the weekend, so probably you may don't feel so fresh about the idea. Okay, so probability. Okay, so I'm not going to go to slide by slide, but the important point I just want to point out. So probability in terms of application for the most purpose is we will be define it as the classical definition, right? The frequency approach is the normal frequency, is a relative frequency. You conduct many times of the experiment. How many times the experiment that favorable to the outcome will be the probability of that outcome. Okay, so that is the first definition. I hope that's clear. And then we learn some, because the way that the probability now is defined in terms of sets. Okay, that's why I have the knowledge of set that with intersection, union, complement, all are basically the set operation. And then we have, based on this definition, we can define what we call the mutually exclusive event, right? Cannot happen at the same time. Exhaustive event, that everything add up together is sample space. And mutually exclusive and exhaustive is something you partition the sample space. Okay. And then we come to a more formal definition of probability, right? We call the something that we think is correct. There's an axiom, we don't prove it, there's an assumption. So the first one is saying that probability must be between 0 and 1. And second is saying that the probability is the whole sample space is always 1. Okay. And axiom 3, we have a weaker form, which says if you have an event that is consists of n mutually exclusive, that's important, mutually exclusive. This is important. And then the probability of that event will be probability of sum of all events. Okay. So this one looks, I think, is very natural, right? Because if they're not affected, the probability of the everything union together with the event, right? They say then should be the sum of that, right? And in fact, if you go more technical, n actually can go to infinity. Okay, we don't limit to the finite number of collections. You can invent the countable infinite collections. Why we need that? Because when we talk about the continuous distribution, right, then we actually need to have that, right? What's the probability that when we draw a number, random number from 0 to 1, right? What's probability from draw a number between 0 and 0.5, right? Then it will involve a continuum of numbers, right? Continuum of outcome. So that we need, of course, in that case, we need some integration, but I mean, summation, right? I mean, some by the integration will be needed naturally. But anyway, for a purpose, that would be fine, okay? But you should remind yourself, this also expand to the idea of continuous infinite number of outcomes. then based on the axioms, and then we can derive the idea we call the complement rule. Okay, we have addition rule. Complement rule means right, it just add up together is 1. Okay, and this addition rule is connecting what is the intersection, what is union. Okay, and you reverse it. This is somewhat okay, and this total probability rule. Okay, if A is partition of S, then we have this, right? Do note that this a particular application of this is which we'll talk about immediately when we talk about the Bayes theorem. So later in this class, we will see if sample space S, right? You can say A and A complement, right? Also partition, right? So that means probability A plus A complement is also 1, right? And okay, so this is something we will use later. Anyway, so next is odd, right? Odd is just a definition of the ratio, right? Is A over A complement, okay? And the against will be A complement over A, right? And we have talked about last time in the class, this is equal to the odd of a fair bet, okay? So this is the odd of a fair bet. So this is something we expect. The same, if a fair, then you should, this thing should be the same thing. Now, the next is conditional probability, right? We covered last class saying that this, by definition, if I know B had happened, what is probably A, we'll update it, right? And the B will be the, because we know B has happened, right? B is the new sample space, right? So then that means that the probability that other probabilities should expand because you know B is already the sample space. So for the A and intercept B should be much bigger, right? Because if you draw a picture in your mind, right, this is the sample space S, right? And this is A, and this is B, say, right? And it should be the case that now no B has happened, right? So only this is true, right? So now this is become the product B, this whole thing should be 1. So we divide them by 1. And only B is relevant. So that's why outside the B is not relevant. So that becomes this, right? This is same as when you talk about the frequency approach, right? So for B, right, will be the ratio of total number of experiment, right? Total number of experiment, right? And number of outcome that favor to B, right? And this A and B will be number of outcome that favorable A and B, right? Over number of experiment, right? And then cancel out, then will be the ratio of total number of experiment B and A and B, right? Right, this is the right definition because now you want to do a lot of experiment that B had happened, right? So that is number of B. This become the new sample space, right? And you want to see how likely the A would happen. Then that is number of A and B had happened, right? Because you only pick out all the experiment that have B, right? And then you, at that point, you pick how many of them actually A had happened. So that is number of A and B, okay? So that's a definition you can follow from the idea you count the number of experiment favorable to the outcomes. Okay? And if you don't follow, doesn't matter, just the definition, you can just memorize it at the moment. And after you do some exercise and you appreciate what it is eventually, okay? But for a calculation, you don't really worry because it's just simple definition, okay? But we try to give you the idea why this is the right definition. And if you follow this, right, you multiply the denominator both sides by probability B, right? Then you become a interesting, we call multiplication rule, okay? And this rule will be very useful later when we talk about the Bayes theorem. We will be using this often, okay? And now we start a new material, but before we do that, any question? Any question? Good. No, okay. That's nice. So let's get started. The independence, they have two parts, okay? Actually, there are three definitions, but what it means is I know B had happened, okay? Whether A happened or not, okay, has no change, okay? I tell you B had happened, okay? Doesn't mean anything, okay? So just like you start a stock market, okay? If you think the Hong Kong stock market is independent of the US stock market, whether or not, you would be judged. I tell you yesterday, the stock market of US has fallen down, okay? Does it change your idea about today's stock market, okay? If you think they're related, okay, you change your idea, then you definitely think they're not independent. But you think I tell you this doesn't really have any impact, then it's not, okay? So that's the idea, okay? And also this actually imply, okay, but I didn't write it here, but you should also see from here, I use the easier one first. Whether B happen or not, so B complement should be same as this one. Okay. And this also set the same for this one. Whether B would happen would not change my idea whether A would not happen or not happen, okay? And of course, these two are the same. So basically you can check anything have to be true. Okay, because here you just swap A and B, just A and B swap, because there's no particular meaning for A and B, okay? And this directly follow from the definition of the conditional probability, right? A intercept B, right, will be A and B times probability. Or maybe I use the better one. So I use the other one. I use the multiplication rule, it's easier. Multiplication rule said probability A intercept B with probability A given B times probability B, right? And if they're independent, so this telling you B doesn't mean anything, it's just A times probability B. Okay, so that is how you would get this statement. Okay, is that okay? So maybe a little bit abstract. So let's see one example. You get some better idea what's going on here. So A is 0.6, B is 0.5, A intercept B is 0.25. Are they independent? okay? And to check independence, you can do various ways, right? One way is to check whether this is equal to PA times PB. That's what we do here, okay? And the other way is to check whether probability A given B is equal to probability A, all right? Okay, we will check this one too. So, but let's see this, okay? A and B, okay, multiply together is 0.3, okay? So, and that is not equal to A intercept B. So ask me is independence and no. So ask me how independence, how is it related to mutually exclusive? Okay, whether they are not the same. And the question is whether they are related or not, right? So the question is how later answer this question, how they're related. The next question is why A becoming A, because that is the definition of whether B had happened or not actually have no impact on A, right? So that tells you nothing about is that okay? So, but maybe answer this question later, okay? But let's finish this one first. So now we want to calculate this, okay? So other way around is probability A and B, okay, over the B, right? So this will be 0.25 over 0.5. So it is 0.5. So it's not equal to probability A, which is 0.6, okay? So someone asks, again, so I answer the question of why they're all, someone asks why, let me clean that up, okay? So let me change this to 0.3, okay? So someone asked me why probability, in that case, right, A and B is equal to probability A and probability B, okay? You can see this, right? And someone asked why probability A B complement is equal to probability A, okay? Why this is true, okay? So let's see if we can prove it, okay? So probability B complement is 0.5, okay? It is direct application, okay? And we know, okay, probability A, okay, can be written as probability A intercept B plus probability A intercept B complement. Okay, because A can be divided in two parts, right? And so here is 0.6. This is 0.3. So what's this? So this is 0.3. Right. Okay, then how to calculate this guy, right? This guy is probability A recomplement, right? Will be probability B complement, probability A intercept recomplement, right? So this is 0.5, right? And this is 0.3, and that's why we're 0.6, which is probability A. Henry, do you answer your question? Of course, here I just give example. Actually, you can prove it exactly why this is true, but you can replace all the number by symbol, then you can see check. Okay, and the question about the independence and mutually exclusive, right? And independence would so go back to the definition of mutually exclusive. Mutually exclusive means it is not possible for if they cannot happen at the same time, right? Independence means mutually exclusive means they can happen at the same time, right? That actually means that actually means if A and B are mutually exclusive, means A intercept B would be 0. Just because they cannot happen at the same time. One is true, the other is false, right? So it cannot happen at the same time, right? Can I say independent events are not in the same sample? No, everything in the same sample space. So independent means if you draw the sample space, okay? Independent means this is A and this is B, okay? There are no intersection. Yeah, this is a Venn diagram here. Yes. But independence, okay, let's see how can we visualize this. Independence actually means that telling you whether A would happen, whether B would happen. And that is not independent, right? Because telling you mutually exclusive actually means if I tell you A, right, actually B would not happen, right? Actually, they're not independent, right? Because if I tell you A actually help you and if B would not happen. Can we use Venn diagram? A little bit tricky, but okay, I try to do it in a Venn diagram, but let me see if I'm doing right or wrong, but let's see, okay? Let's give you an example in a Venn diagram. So this is a Venn diagram. I try to do it out of my, so let's think. So suppose, let's give an example. So I know A happened, okay? It's more like proportional idea. Maybe I move to a whiteboard, okay? So suppose this sample space, okay? I just give a very special example of independence. Maybe textbook has better, but I just think off the mind. What happened? Telling A will not change to B, right? Telling B to A. So you can imagine something like the following. So I think B here has nothing, maybe the sample, okay, let's see the following. So maybe do it in this way. it's something like, let me think. I need to think about this, but okay. So from definition, so remember the definition is like this, right? This is A, right? And this is B, right? So the definition is the following. Probably A times bar B, right, would be equal to the probably A intercept B, right? So which means that this, if you consider area probability, so this area, right, will be the area or product of these two areas. That is the Venn diagram set. So what it means is suppose the sample space have 10 element, O1 up to O10, okay? So what it means is suppose we have maybe up to 100, maybe easier 100. And suppose A have 30 element, suppose, right? B has 20 element, right? Then this will have 6 element, okay? In that case, and each element would have equal likely, right? Then it will be independent. Telling you A will not have changed B, tell B has changed A. I think that would be the idea. Is the if you think the probability area or number of outcome, then this is the way. I don't know I answer your question, but I do not recall any example of Venn diagram here, but it's somewhat as maybe there's some way, but I at the moment I do not recall what is the, or maybe this is maybe one of the other way. So let me try another way. Something like if this is sample space, if a square, this is A, just the size, this is size. It is a B. I don't think it's a good Venn diagram, but it is the probability area, and this is somewhat AB. So this is relative probability. This is size, somewhat like that. But anyway, I'm not sure we have a good Venn diagram for that. But I don't know answer your question. But let me think a little bit more if I see if I put a good Venn diagram for that. The answer you any question, Peter and also Henry or Hoeing. Henry, did I answer your question? But I'm not sure whether we have a right definition for that. But maybe I will try to figure out anything that would answer your question. But just go back is independence and mutually exclusive. Of course, is if the mutually exclusive means there's some relationship. Okay, so it cannot be independent. It's a good exam question. I never thought about that. Good. So go to the next one. So here comes the most important idea about the this class is Bayes' theorem. Sometimes people refer to what we call the Bayesian learning. Okay, and of course, this is related to what we call the AI learning. Okay, and this is or Bayesian updating. Okay, Bayesian updating. Okay, of course, Bayes' theorem is the basis for Bayesian learning based updating, and of course, it's a part of the AI. AI, probably you know, is a intelligence, right? And the software that try to learn, right? And how you learn is you have some information, try to train, right? Try to make the program smarter, right? And how to train, right, is how you update it, okay? And the main idea of the Bayes theorem was trying to learn how to update based on new information, right? We have some idea about certain thing, right? That's called the prior and posterior, okay? And or something in more general means you have some information, okay, some idea about something, okay? And someone give the news, okay? And then, okay, you become smarter, you know, new information, right? And that is how you come up to here is the Bayes rule. Okay, and what it is you have some idea about the world. Okay, idea about the world. Okay, which usually we call probability A. Okay, it is A. You can consider A. Okay, is state of the world. Okay, usually is unobservable, unobserved. Okay, something you are trying to infer. You can imagine A is, say, the patient case medical test is A is whether a guy got disease or not. Okay, you don't know whether he got disease or not. You want to try to guess what's going on. Okay, B is more like somewhat like experiment. Okay, or there's no new information, right? New information. Okay, in terms of finance, right? Information, or you accounting, whether you do some audit, right? And of course, this outcome of the right? Outcome of the experiment, outcome of the audit, right? And based on this, you try to see what this is about. Okay, so let's give you example, right? So the example is the following, right? So you have A, maybe there will be two outcome. The simplest case, A can be two outcome, A1 or A2, okay? And I use a color, maybe better. A2, maybe black, in A2. A1, maybe you have the disease or you don't, all right? There's a case where you do a blood test or any kind of medical test, whether you have the disease or you don't have disease, right? Or you want to see the medicine you show or not, you have either you got cure or not, you do not get cure, okay? And now you are going to have the treatment, right? Maybe sometimes we call experiment or we call treatment, right? And you're going to do treatment, okay? After the treatment, there are two possible outcome again, 2 by 2, right? Two possible outcome, whether the possible outcome is either B1 or B2, okay? B1 or B2, okay? And B1, maybe the test is positive, okay? B2, test is negative, okay? So what actually we are trying to do here, okay, is we don't know you are have or you don't, okay? What we can see is either B1 or B2, okay? Whether you have the outcome of test positive negative. We try to infer whether you are in A1 or A2, whether you have the disease or not, okay? And if disease, we can do operation. If you don't have, you don't have operation, right? Or you have a disease, we're going to put it in stay home notice or put in hospital, okay? And okay, so then we repeat, if you try to observe B1 or B2, okay, but you don't see A1, A2, okay, but we try to guess what's B1 and A2, okay? And what we have is the data, I know whether you are, how likely you're A1 and A2, okay? And I know how this thing, I know how this. Given you A1 or A2, I know how accurate the text is, right? If you're diseased, usually it's very likely you would give positive result. You may have false positive, that's fine. If negative, okay, very likely you also negative. But you also have false negative, which is here, right? So the question is, if I see positive result, how likely you are here, okay? Just probability in this case is, what I care is probability of A1, right, given B1, okay? Other things are important, but this is the most important thing you want to care, right? So is it clear what's going on here? The Bayes rule. Is that okay? Maybe I give another example, which is somewhat more common, right? Maybe I use the whiteboard. So if you watch TV shows, right? Especially the Korean or Japanese one. Yes, we're trying to, yes, okay, yes, exactly. So very often, right, in a classical Japanese drama or Korean or even Chinese or whatever drama, right, there's a girl, right, okay, and this is a boy, right, and the girl want to see if the boy has some feeling, right, ask whether the boy has some feeling to her, right, so there's two outcomes here, right, either there's some feeling, okay, or there's no feeling, okay. So this had feeling with the A1 and have no feelings A2, okay. And what we see here is the girl want to see if there's a boy have any feeling, right? Then maybe what the girl try to do is, I think classical Japanese thing is you send, I think if I'm correct still, is you would do this, right? You would send this thing. What's this? Chocolate, right? Okay, send the chocolate to the girl. Okay, and there will be usually two outcomes, right? The boy may say, for simplicity, but then the boy died in a crash. Oh yeah, that's true. I mean, unfortunately, that is usually the case. But so if the boy likes the girl, usually the boy may send back, I don't know, send back something. Maybe if the boy likes her, maybe maybe there's some flower. Okay. Okay. Send back the flower. If there's nothing would happen, there's no flower, unfortunately, right? So this is B1 and B2, right? And but even though the boy would not have anything, don't like the girl, maybe out of courtesy, he want to send back some gift, right? This is also possible, right? Sunflower as a friendship, right? So still B1 and B2, okay? So now the question is, where this is the question we want, right? The girl want to see if the boys have any feeling towards the girl, right? Just what we care, right? Is whether there is a romantic relationship, right? And given the boy actually sent back the flower or sent back the cloud, okay? So that's a question, okay? And of course, the girl will have some idea how likely this would happen, right? Has some idea, maybe 50-50 or more than, of course, usually more than 50-50, right? You start this, right? Maybe they know each other, they well, maybe they have fun and whatever. There's some interaction, you know this. And also this is based on this, right? This is very likely, right? And this is likely, but still there's somewhat likely here, right? For friendship reason. And this is very unlikely, right? So you want to try to guess what's the case. Okay, is it clear what we're doing here? Yeah, Queen is right. I mean, at the end, the boy will go to car crash or the girl go to car crash, right? And yeah, that's very often, but that's a part of the drama. But kick out the drama, that's what it is. Is that clear? Good. So let's go back to the idea here. Let's click. So here we have probability A given B, right? But just by definition, right? The conditional probability set is probably A intersect B. Okay, sorry. Okay, and A intersect B can be written as probability B given A times probability A. Okay. Okay, and in this case, okay, so that is the base rule. Okay, basically you can see this get swapped. Okay, so basically if you go back to the oh, I think the slide's gone, but just you update yourself. Okay, but anyway, let's see the example then with a break. But sorry, a little bit delay for the break, but I hope that's okay because so this is the proof I have. Just start from here, right? Definition, you put the multiplication rule, and this is what we have, the base rule. And a special case here is we have partition sample space, right? And the denominator is still the probability B, okay? But just they are partitioned, so that makes things easy, okay? But let's see the example, then you will probably see what's going on, okay? So here I have population of 40% is infected with a disease, okay? And I have a medical test that's 80% accurate, okay? That means if you have the disease okay, then you have positive is 80%, okay? And you have false positive, which means that if you have no disease, you still positive of 40%, okay? And what's probability one that infected given the positive outcome, which is asking is actually probability, okay, of given you're positive, what you have, right? So that's swapping these two, right? You know this, you want to learn this, okay? So that is what we're trying to do, right? It's just, I want to see if the patient that actually got positive result would have the infected disease, okay? So now just replace everything with our notation, right? Let's say A is positive, B is infected, okay? I use black color, maybe blue color, okay? So B is infected, so which means that unconditionally, you randomly draw a guy is infected 40%. So that means probability B is 0.4, okay? This is exactly here. Okay, you see it. Okay, and half is B, right? Positive A, right? So that's why A given B is 0.8, okay? And no is B complement with A, okay? So that's why we have this here, okay? The question is whether you have is B given A, okay? So that is what it's asking, okay? So that's what's asking. So to do this type of question, if you are the first time to do it, you just find whatever is there, apply every rule, you find everything, then you should be able and then you try to see what you need. That is a simplest case. So the first thing I do is B, probably B, right? I want to find the B complement. Okay. Then it's coming from that is 0.6 because 0.4 have and 0.6 don't have. Okay, I hope that is clear. Now what we want to do is to remember this. Okay. The goal is this. I remember that, I never remember the formula. So I always start from the beginning. Okay. For B given A, I will start from the beginning is the definition, probably A, probability A and B. Okay. So that's why what I'm going to do is I would want to find the denominator first. Okay. Actually, in doing the denominator, actually, I would figure out what is the numerator. Okay. But first is this will be true. Okay. Probably A, okay, can be written as A intercept B and A intercept B complement. Okay. The reason is very simple, right? With S, with A, with B here, right? A is can be divided into two parts, right? The red part is A intercept B complement, and the blue part will be A intercept B. Okay, so A can be written in two parts. Okay, and now I use the multiplication rule. Okay, A intercept B will be A given B times B. A B complement will be A given B times B. Okay, and we do know A given B is point A right here. Oh yeah, there's a typo. I will mention it. And point B is 0.4. Okay, and point A given B is 0.4. Right, it's here. Okay, and 0.6 is here. Okay, and this is 0.32, and this is 0.24, right? And should be 0.56. Yes, you're right. Someone remind me already. I didn't change it because I think I uploaded it. I didn't update the slide, so I should have updated the slide. So this is 0.56. Okay. Yeah, thanks for letting me know then, Yunsu. Is that clear for this part? Is it okay? Now, actually, we're almost done because actually, I don't go to the next slide. This is 0.56, right? And this guy is actually, we have that here, right? It's actually here, this part, right? Actually, it's 0.32. Okay, so what is here is should be typo here, 0.56, right? 0.32. Okay. You can use calculator to calculate what it is. I use my phone to do it. So 0.32 over 0.56 is 0.54. Okay. So that is the result. Okay. So I guess there's a break here. In the break time, you may ask me a question. So let's resume 15 minutes later. So it will be, sorry, I delay a little bit. So it will be 11:41. Okay. But in the meantime, feel free to ask me a question. Let's have a break. But please feel free to ask me the question. Oh, okay. Multiplication rule. Multiplication rule is basically the opposite case of the opposite, just basically coming from the the conditional probability. Okay, you multiply both sides by probability B, right? Cancel out, so give you probability A intercept B will be probability B plus A, this one. Is that okay? 互赢，后赢。So which part is not clear? Oh, sorry, there's a type. Oh, sorry. Sorry. I guess. So A and B is just saying that given that you probably B times what B had happened and probably A. So basically you can imagine join probability of A and B together, right? You just first count how likely B happened, okay? And then give happen how many probability A had happened. You multiply the same thing. So you just divide it into two steps. So the application of this is here, right? Here's the example here. You have three bird urns and three white balls, right? I want to see what both ball are black, okay? You can do the formula in this way, okay? But you can also try to do it by counting how many white ball and black ball together. And this is much easier to do it in this way. I'm not sure I answered the question. But this is nothing but the definition of conditional probability. But this rule is just basically telling us things are getting easy. I'm not sure I can have the screenshot, but later you will be uploading the video, then you can find it back and have that. Is that okay? Because it is gone. I cannot. But you can ask me which part you want to know more. But I cannot go back because I didn't take a screenshot. Sorry. By the way, if you want to take the screenshot for which slide, I can do the screenshot from my side, or you can ask me to pause. You can take a screenshot. I'm sorry, you can pause a little bit for that. Yeah, sorry for that, but you can try to see the slide upload, so the video upload later, then you can try to take it again. Yeah. Sorry, I'm a bit hungry. I ate something. I hope I think it's okay. I mute my mic. Sorry, I'm a little bit hungry. I guess I answer a question. Someone asked me, independence, no, mutually exclusive means they cannot happen at the same time, okay? Mutually exclusive, for example, is now I'm in CHK, but I cannot be in CTU, right? CTU and CHK are mutually exclusive. One happen doesn't imply the other. So that's why in the Venn diagram, you would have a completely separated one. Let me share whiteboard. Okay. So mutually exclusive, if you draw a Venn diagram, okay, they have no intersection. The definition is A intersect B is empty. Okay, so that is exactly what you mean for the when. Is that clear at this point for the mutually exclusive? Okay, and what is independence? Okay, and clearly it's not independent. First, mutually exclusive is not independent. Why? Because if A has happened, B will not happen, right? And B has happened, A will not happen. So you tell you something, it will change, right? So that means probability A given B cannot be probability A, right? Because actually probability A given B is actually 0, right? This is what it means, right? Because A and B empty set, actually this would imply this. Okay, so that is what it means first. And what is and also remember, they may not happen at the same time, right? Telling you B has not happened, okay? Telling you B has not happened, may or would change whether you evaluate. So this would not be equal to A, right? Because if B is not happen, right, it's gone, the sample space shrink. Okay, so A would be can be more likely or less likely. Okay, so that's not the same. So now what's independent? Independent means I tell you this information doesn't change a lot. Okay, so at the break, I try to figure out what is the graphic, and actually turned out to be same as what I have drawn. Okay, I try to figure out what's going on there. What they write is, you can see the Google, I try to Google it. Turn out to be what they write is, they just write this area. Okay, if the area represents proportional probability, just like this area A and B, okay, is as what he says is proportional to the area of the product. Okay, there's nothing new here. Just saying that happened is very intuitive. Telling you B cannot change your A. So that is the idea. If you think more independent, okay, you think whether it is raining now or not, right, should not have any impact on say tomorrow I eat breakfast, whether I eat orange or apple. Okay, that's completely unrelated, then it's independent. Or whether, okay, put it this way, whether I eat an apple today or not have no impact on tomorrow's stock market. I don't think this, I think these two are independent, right? I don't see how they're related. Is that clear? I'm not sure whether I made it clear. Lyman, okay? So to repeat, mutually exclusive means they can't happen at the same time, and that's it. Okay, that's what it means. They cannot happen at the same time. So one happened, the other will not happen. But of course, they may not happen at the same time. They may all false, but just the only thing is they can't be true at the same time. And independence actually just means that intuitively, exactly what I mean is telling you this information have no benefit of predicting where the other one happened. Is P times it? No, only if they're independent. So someone asked me whether this union, oh, no. Ask me whether this is true. No, this is false. It is only true the intersect if they're independent. Okay? If they're independent, this can be true. Okay. And what is union here? Remember the union, the formula will be PA plus PB minus this. Okay. In case of independence, it can be written as A and B, but I don't think we can go further than that, the union. If they are independent, you can go in this way, independent. Okay. Oh, where is the independent? Okay. But if they are mutually exclusive, this becomes 0. So can be written as the adding. Okay. Okay. So that means if you try to, if you really want something to look at in terms of formula to make you happier, you can do the following. If they're dependent, the intersection, independent, to catch on, independent, imply this happen. Okay. Oh, independent means this. And mutually exclusive means the intercept will be empty, 0. Okay. And then the union will be just A plus B minus the product. Okay. For mutual exclusive, A union B will be just, okay. I hope that is clear. They are very different. Is that clear? Of course, you can easily see that if what is mutually exclusive cannot be independent, right? And the independent can be mutual because they are, unless very special case, they can be true at the same time. But unless they're all, I think they're all 0, then maybe yes. But otherwise, they're a completely different thing. Is there any further question? Okay, if no, then we go back to the quickly last part. No, sorry. This is not the screen I want to share. Oh yeah. So counting. Okay. Now I have 2 tasks. Okay. So why I need counting later, you will see this is sometime you calculate probability, we need some counting. Okay. And I just this not in the textbook, but in the online textbook, if you, I think you have the e-version, you have that. But anyway, it's not something complicated. Okay. If the n way of doing the first task, n2 to the second task, there will be n1 times n2 way to complete the mission. Okay. Say the first mission. Okay. There are n1 way to do it. And after first mission, there are n2 way to do the second mission. Okay. And how many different ways to do it is they multiply together. Okay. And you can easily see this is from a table, right? N1 and N, this is the first, this is second, right? There will be 1 up to n1, right? And 1 up to n2, right? So this is the way that you're going to do, okay? And if the case task, then you start from n1 up to nk, multiply together, okay? So that is not very difficult. I hope that's okay. So the next will be try to show you how you form a mu. I guess this is something you can find in the in some I don't know, some of the canteen, right? In CU, right? You can eat rice or noodle, right? I think it's spaghetti. You can have pork, you can have beef and chicken. You choose one of them, right? You can have black, white, and red, right? I think when I was a student here, I think it's just cost $9 or $10, right? Someone told me now become 13. So the inflation is okay. After 15 to 20 years, is just 30%. It's okay. So you have 2 choice here, 3 choice here, and 3 choice here, right? So how many of them, right? Is multiply. Is that clear for this part? So why we need this? So one often the question is asking, suppose I randomly pick a meal, okay? What is the probability I pick a pork, okay? So then the answer would be the denominator we know is already 18, right? The 18 combination. And suppose you choose a pork already, right? Then what you left is 2 times 3. Okay. So that means it's 1/3 of the randomly selected contain pork. Okay. And the other question is what is probability that they randomly have a black sauce with the beef. Okay. Black sauce beef only 2 choice, only 2 choice here because only either rice or noodle of 18. So it's 1 of 19, 1 of 9 people you would be using the black and the beef. Is that clear? Why we need to talk about the counting? Because this probability we need to handle it. Okay. The next part is permutation. It's a kind of counting, okay? But what you do is putting the object on a line, okay? The linear order is on a line. So what we do is suppose you have n balls, okay? You put all the balls on a line. How many different ways to do it? Okay, suppose you have ball 1, ball 2, ball 3, right? You put a line, can be 1, 2, 3, right? Can be 1, 3, 2, can be 3, 2, 1, can be 3, 1, 2, can be 1, 2, 3, there, sorry. Should be 2, 1, 3, should be 2, 3, 1. So there's you can see there 1, 2, 3, 4, 5, 6 ways, right? So how do you count it, right? You don't want to list them all, right? But you only have 3 balls, means there are 3 spots here. How many different ways to do the first task? 3, because you can put 3 balls. Once you put 3 balls, only 2 balls left. There are only 2 ways to do second ball. And that's the last way to do the 1 ball, only 1 ball left, right? So it's 3 times 2 times 1, okay? You can generalize if you have n balls, then the first thing to do is n way to do it, and n minus 1, and so on and so forth, right? So that you have this formula. N factorial is n times descending order. Each time you minus 1 up to 1, okay? And sometimes you don't want to use all the balls. You only want to take R balls, right? So stop, instead of n box, you have start from the first box, second box, up to the R box, okay? Then the first thing you do is n and n minus 1, The last one is n minus r plus 1, right? Because it's n minus r minus 1. Because the first one is n minus 0, right? You count from 0 up to r is r minus 1. So this is the thing, because you can rewrite it n factorial o minus n minus r factorial. And because this is often used, this is called NPR, okay? But you can always start from the first principle, okay? It's not something you need to remember, but it's so often used, people call it NPR, okay? Or in calculator, sometimes you see NPR, okay? Or in the textbook, sometimes you see some textbooks N comma R, but they're the same thing. Is that clear at this point? Any question? If no, we try to make hamburger. Okay, you make some hamburger. Now make hamburger. Okay, suppose you go to the fast food restaurant and do some hamburger. Okay, and hamburger, there's 3 types of bread in this hamburger shop: white, Italian, or whole grain. Okay, and hamburger is more fun. You can choose 2 ingredients: vegetable, beef, egg mayo, chicken, tuna, and tomato. Okay, and the question is how many different possible hamburgers. That means suppose you go there and eat each day a different hamburger. Okay, how many days you can spend, right? This is sometime you try to do, right? And in this particular case, I would consider the hamburger. Okay, suppose this is a hamburger, right? And you try to stuff some egg mayo and some chicken. Okay, it's not the same as you have some egg here, okay, and the chicken here. Okay, they're a different thing. Okay, we consider different thing because the chicken sauce can go down right here, but not the other way around. Right here, the chicken sauce goes to the bread, right? Not the way around. So we consider different burgers. So how do you do that? This can be considered 2 tasks, right? When you try to fill bread, there are 3 choices. Here you have 2 out of 6 ingredients, right? And we said the order will matter, right? So we have the 6P2, okay? So it's 3 times 6 times 5, okay? Which is 90. Okay? So now here comes to the, is that okay? Now comes to the end, we have combination. So combination is the same. Oh, by the way, I forgot the application. The combination besides this is take pictures, right? Suppose you have 4 people right now, right? Because now you only have 4 people go to restaurant, right? The first thing you do, right, in the restaurant is to take pictures, right? And then you can consider 1, 2, 3, 4, right? And take pictures. And take pictures, there are 4 different, how many ways you can do, right? It's depend on how many people you do, right? 4 people, then 4 factorial, right? But if you just there only have 3, right? Only can accommodate 3 people, right? Only have 3 people, right? Then you'll be 4P3, right? Why 3 people? Maybe there's some setup here. You can just take 3 picture of the 3, right? Anyway, this is the application. So the next talk about combination, right? Combination is instead of a line, you want to take out R ball from N balls, but the order doesn't matter. What's example? Maybe you try to form committee, right? Then commit order doesn't matter. Or I try to see we have 60 people here, right? And I want to form a group of 2, right? How many different group I have, right? So the order would not be matter, okay? So the notation for this is called NCR, okay? Actually, it's closely related to NPR. Why? Because now I don't consider the order matter, right? Then you just divide them by R factorial. Because for each thing you take out, right? For n ball, you take out r ball, right? And for each r balls, you can rearrange them, right? Which is rpr, which is r factorial, okay? So that's why NCR and NPR are related by a factor of r factorial. Is that clear for this point? Right, because for everything you take out the line, you can rearrange them, right? For example, 1, 2, 3, 4, right? If you take out the 4 element there, you can take 1, 2, but 2, 1 is also the same, right? So that's why if you say 4p2, okay, over 2 factorial will be 4c2, because 1, 2, and 2, 1 appear twice, right? And you have a 1, 3, and 3, 1, right? But they should be the same, right? So that's why you every time double count twice. Okay, I hope that is clear. So now we go to a canteen near the B school, right? So you have noodle and rice, right? You have sausage, spam, ham or egg, black or white, right? Hamilton meal. And the answer would be you have 2 of this, right? 2 of this, right? This is 4C2 here. 4C2 here is 4 times 2 and 2 times 1, 4 times 3. Okay, then it's 6. So 24. So here, in this kind of meal, you can eat a month almost, right? Because you discount the Saturday or Sunday, right? Then almost this meal, you can rotate a month without a problem. Okay, so that is usually what you do. Okay, is there any question at this point? Any question? If no, I will briefly talk about some Excel. Okay, so I will talk about how to calculate the range, because mean, median, mode, those kind of things. I want to talk about how to find median. I want to talk about range, and I want to talk about IQR, because that will be useful for your assignment. So let me open the slide for the probability Excel. So I want to talk about this max, mean, large, and small. Okay. So max and mean, large, and small. So by definition, it's very simple. Max will give you the maximum value. Mean give you minimum value, right? Large will give you the in the ascending order, right? Small will give you this descending order value. Okay. So small will give you the ascending order. Large will give you the descending order. Okay. So see the example. So max of this will basically set, just a typo here again. So this will be the max. This will be the max. So mean. Okay. And here the max is 4, so this gives you 4. And the mean gives you 1, so give you 1. And here largest, I pick the second one with the 3, right? Small, you come up from the 3, small, right? The 3, so small with 1, 2, so we give you 2. Okay. Is that okay? Is that okay for this one? No question, right? Okay. So let me work it out in this. So let's go to the slide, I guess. So let's go over how to find the max and the mean. Okay. So this is data. Okay. We have 2, 3. Okay. And can you see my Excel? Can you see my Excel? Yes. So I want to find the max, right? Find the mean, and then why we want to do that? Because I want to find the range. Okay, so that's a goal. So the max will be just do the max, B2 up to E2, sorry, B1 up to E1. Okay, the max. The mean will be mean B1 up to E1. So in case you don't see it, this is something we want to have. Okay, and the range will be just B2 minus B3. Okay, that's how we find the range. Is that okay? Good. So I want to skip the rank. Want to talk about the percentile first. Okay. Percentile or the quantile, in fact, both of them I want to talk about is it's a little bit trickier than what we taught in the class. Okay. So what we taught in the class is, I think we taught in the class is the exclusion method. Okay. Is actually this is what we when we find interquartile range, right? And that's what we do, right? We are trying remember that we're talking about find the oh sorry, I cannot draw on the sorry, I should show you this. Sorry, I should show you the slides. Sorry, I forgot the slide. So what we're doing is I skip the rank part. I want to talk about the percentile and the quartile. Okay, so the thing we would be actually you can see that you see the Excel that we went to percentile, quantile that we could exclude and include. Okay, so the formula is rather complicated, but you see I think the thing we do is I think what we're doing is doing the exclude one. Okay, the exclude one is the one we taught in the class. So remember what we are doing in the class is the P times N times 1, right? It's equal to K, right? And if integer is K is the answer, right? If not integer, then we will do interpolation, right? That's exactly what actually we're doing. And but the problem of this formula, when sometimes when you apply in the quantile is no problem, but when we apply in the percentile is a problem, because when P is very small, it's lower than the data set, then it will be the easy. Okay, you give you error when this thing would happen. Okay, otherwise they will interpolate. Okay, but anyway, percentile is something related to quantile. Quartile, remember, is just we cut it into 4 parts, right? Q1, Q2, Q3, Q4, and Q0, right? Cut them into 4 different pieces. Percentile, oh, here cut 3 cuts, okay? And percentile is cutting into 100 parts. So you cut 99 cuts, okay? Then will be P1, P2, up to P100, okay? Of course, a P0, okay? And then you apply the same formula here, okay? But the only thing is you have include, exclude. So let's see why that's the case. And you will see if you have I think there's a typo here. This should be exclude. Okay, this should be include. Okay, and if you do it here, the exclude would have some problem when you go to the boundary. Okay, and but this is fitting our intuition. Why? Because you have remember you have 1, 2, 3, 4, 5 data point, right? And the 15 percentile, right? It should be the median, Q2, right? 25 percentile is called Q1, right? And 75 percentile is Q3, okay? And you have 1, 2, 3, 4, 5 data point, right? The median, right, will be 5 plus 1 over 2 rank, right? Should be the third data. 1, 2, 3, the second one. So it's 2. So both give you the right answer, okay? And the second quantile, right, should be 1/4 of 6 data, right? 5 plus 1. So it should be 1.5 data, right? 1.5 is the average of these two, right? Give you 1.2. So 1.5, okay? This is exactly the exclude is something I want to use, but you can use include that you do other way, okay? Why you do this? Because remember the formula they have is instead of P times N plus 1, they have P times N minus 1 plus 1. So the case is a little bit different, okay? So that they give different formula, okay? But this different formula has a good thing is everything is well defined for everyone, but it's not the same as what we used to do, okay? And Q3 will be the 4 over 3 plus 6, right? And then this will be 4.5 data, right? So it's 1, 2, 3, 4, 5.4. It's 4.5. So this is average of these two. So place it to percentile. Okay, and this percentile will carry forward to the quantile. Okay, so this percentile data, okay, is clear. Okay, this is just P equal to 0 for the percentile. Okay, and same for the rest. Okay, so that's why you should be able to see when you actually do this, like the Q1 and the Q3, same as the P equal to 0.25, P equal to 0.5, P equal to 0.75. Okay, so this is the quantile. Of course, this is median again, right? This is median already. Okay, so you can find the median, find the Q1, find the Q3. Okay, so you should be able to calculate everything if I ask you to use Excel to do the calculation. Okay, so before we end, let's do the quartile in the Excel spreadsheet. Is there any question? Okay, we'll quickly go to the Excel spreadsheet. So let's see it. Let's see the data. Okay, data. We have 1, 2, 2, 4, 5. Okay, and then we just calculate the quartile for the time. So we'll quartile. We'll do quartile exclude because this is what we teach in the class. So we have the smallest number, Q1, but they use 0. Okay, this Q0 is the minimum. This Q1, Q2, Q3, Q4. Okay, and we use quarter exclude, and Q3. This is K. Okay, so this is data with the data first. The data is B1 to F1, and because I want to copy and paste, so I use absolute address. This is data. Okay, and then I base on the input of A3. Okay. Okay, but the first one is not available. So, okay. And of course, that gives you the median Q1 and Q3 in our understanding. Okay. Is that clear how we find the quantile median range? Okay. Then the case there's no problem. Then I will see you on Thursday. We have a quiz. We're short. We'll try to use Blackboard this time. I guess you reply seems to be a little bit difficult. So let's try to do Blackboard, and let's see if this is better. If it's better, we use Blackboard. Otherwise, we go back to you reply. So, but don't worry, it's participation based. So you do it, you get the credit. So don't worry about that. I will see you on Thursday. Thank you. Bye bye. Yes, I would expect you to use the exclude because this is fitting what we teach in the class. But of course, you can do. I mean, if you're not following our class, you use your own measurement, then you just write down I'm using the include. Just to avoid trouble. If you don't specify, I assume you're using the exclude method, okay? Oh, there will be, I will talk about that next class. Oh, what is the difference between include and exclude? So in the quantile actually using the percentile method. The difference is this one. The main difference is they use the K, they use what we have. Sorry, I should share the share screen. So it should be, so you can see the include exclude. The only difference is the K, what they use. Okay, this is exactly what we learned in the class. Okay, this is the definition of KK. Some people ask me is quiz 2 and homework material. Yeah, I will do it totally because I want to see how you do the quiz 2 and then I decide the homework. I mean, I have homework, but I will try to see if I need to give you more practice. What's the formula type on B3? Oh, so I go back to the share again. Oh. B3. So that is quantile exclude. I have the B1 to F1, the data, and A3 is this entry. I'll upload. Did I upload I think I upload the first one, right? I think the second one will be there too. Yeah. Any further question? Yeah, feel free to unmute your mic and talk, or just leave a chat over there. So can I help anyone now? William, Pauline, Tani, Kelly. Any more questions? I'll give you 2 more minutes and I will end the Zoom section. No question within 2 minutes. Good, good, good. So let's see if anyone have more questions. Okay, since no more question, let me end the section. So I will be seeing you on Thursday.